All right, boys and girls, welcome back to the drive-through for part 2 of 7.5. There may be a part 3, or I might just make this a long video. We'll see how it goes. Still colder than a polar bear's toenails. All right, so hopefully you've read this through. If not, let's pause the video and do that. Okay, so the first thing, it's talking about optima and Jenny again, but really the only thing it says, fully described the parabola that Jenny has assigned. So it's facing up because the number in front of there is a positive 1. It's positive. So it's facing up. It has gone right 3. It has gone up 4. And the vertex is at 3, 4. Okay? Hopefully that you understand that. All right. So, Jenny returns to her homework, which is about graphing quads. Much to her dismay, she's found she's been given that. Oh dear. I can't tell where the vertex is in order to identify the transformations. Wait a minute. Is this a perfect square? Now, here's what I want you to understand. At this point, if you don't understand how to do this completing the square thing that I'm going to work to you at, then what you should do is just put this into your calculator and find the vertex. I will do that for you one more time, but hopefully you watched the other video. X squared minus 6x. If this is going too fast, then you need to watch the previous video. All right, graph. Okay. Let's calculate the minimum. Get my water bug to the left of the answer. Hit enter. Get my water bug to the right of the answer. Come on, come on, come on, come on, come on, come on, come on. Hit enter. Would you like for me to take a guess? Yes. 3, comma. Now, as I told you before, it's going to confuse you sometimes. This right here represents 0. It's 0.000012 times. It's given it to you in scientific notation. So I can use my graphing calculator to find out that the vertex is 3, 0. Oh, cool. Well, then that must mean that I could also write this as y equals x minus 3 quantity squared plus 0. Well, that's what they're talking about. Use the work from building a perfect square to see if this thing is a perfect square. Yes, it is. It's a square where this is x by x, and then we have now, I'll use blue to indicate subtracted. We have subtracted 1, 2, 3 from each side. 1, 2, 3, and then we also have added 9. Okay, that's x minus 3 times x minus 3. It's x squared minus 6x plus 9. Or another way, so it's saying, what's the form of the new equation? Y equals x minus 3 squared plus 0. What is the vertex? 3, 0. Graph. Okay, well now that we have it in our, look, we have that in here, so look, just go to our table, and if I just use a blue line as my vertices, okay, and I'll graph this thing in red. Okay, 0, 9. 2, 3, 4, 5, 6, 7, 8. This is 9. Okay, 0, 9. 1, 4. 2, 1. 3, 0. 4, 1. The symmetry points are a lot easier to plot. And that red parabola is the graph of this and of that. It's the same exact graph, same exact equation. It's an equivalent equation. Okay? The next quadratic on Jenny's homework is this. Does this expression fit the pattern for a perfect square? No, it does not. If it was a perfect square, it would be x squared plus 4x. What's half of 4? 2. 2 squared. 4. That is a perfect square. So, no, the 2 needs to be a 4. All right, use an area model to figure out how to complete the square so that the equation can be written in vertex form. All right, I'll do that. Use an area model. You've got x squared. You've got 4x, so that's going to be 2x there and 2x there. And see, what we have is plus 2. So we have 2 squares that we're missing. We're missing that one and that one. So it's 2 short of being a perfect square. That's the area model. Is the equation that you have written equivalent to the original equation? No. So the perfect square would be y equals x squared plus 4x plus 4. So what, this thing. So what would we need to do in order to adjust it? Well, we would need to add 2 to it. Are we allowed to add 2 to it? No, we can't just add 2 to this side. This is illegal because this equal sign is very powerful. It's saying that things are the both sides. So we have to add 2 to this side as well. Well, here's how you do this. And again, you don't need to know how to do this if you're just going to use your graphing calculator. But if you had y equals x squared plus 4x plus 2, here's what you do. The completing the square technique consists of putting parentheses around that. Complete the square on the inside. So, what's half of 4? 2. What's 2 squared? 4. Now we have a perfect square in here. That's what we wanted. However, if I add 4 right here, I have to subtract 4 somewhere else on the same side. If Jimmy's on the teeter-totter and he gains 4 pounds, then in order for this teeter-totter or this seesaw to remain balanced, then someone else on his team would simultaneously have to vomit 4 pounds so that the teeter-totter remained stable or equal. Okay? So now look, this black thing is a perfect square. What is it? It's y equals x plus 2 squared. What's 2 minus 4? It's minus 2. So now I know the vertex. That's the whole point. That is the entire point of completing the square, is to find the vertex. What's the vertex? It's negative 2, comma, negative 2. Well, how else could I have done that? I just could have put this in my graphing calculator. That's my whole point. That's what I want you to understand. At the beginning, you could just put this into your graphing calculator and then find the vertex that way. I don't care how you do that, but now I'm ready to graph it. Okay? So let's put this in my graphing calculator. Y equals x squared plus 4x plus 2. Let's just go to the table. Okay. I need to scroll up because I don't see any symmetry on there. There's the symmetry I'm looking for. So let me put my axes on here. Just imagine that that's going through the one I want it to. All right, negative 4, comma 2. Negative 3, comma 1. Negative 2, sorry, negative 3, negative 1, pardon me, negative 3, negative 1 down here. Negative 2, negative 2, 0, 2. Look, this is exactly what we predicted. Okay, the vertex is negative 2, negative 2. I can either do that by completing the square, or I can use my graphing calculator. For the rest of this video, I'm going to complete the square. Okay. All right. So, how to figure out how to complete the square when it's an odd number? Okay. So here's what we do. We're going to rewrite it just like we said: x squared plus 7x. Put parentheses. Leave yourself space. Okay, and rewrite the plus 10. So 7 divided by 2 squared. That's 49 over 4. Okay. Now, I just added 49 over 4 to the right side of the equation. Well, then I better also subtract 49 over 4 from the right side of the equation, because I got to keep this thing level. Okay? So what is that? Well, that is x plus 7 halves squared. Oh gosh, 10 minus, let me pause. So that's 40 over 4 minus 49 over 4. Right? So that's minus 9/4. Okay. So you could also rewrite this as x plus 3.5 squared minus 2.25. So what is our vertex? Our vertex must be negative 3.5 comma negative 2.25. Okay? All right, don't worry if you had to think hard. We've got some more to do. So what do? I rewrite this as g of x is x squared minus 5 x parentheses with space plus 3. What's half of negative 5? Negative 5 over 2 squared is 25 over 4. So I added 25 over 4, so I have to subtract 25 over 4. That gives me x minus 5 halves squared. Okay, that's 12/4 minus 25 minus 13/4. You could also write this as x minus 2.5 squared. That's not an 8, but it looks like an 8. So now with the ViewSonic, I have to go backwards. 2.5 squared minus 3.25. So what's the vertex? Positive 2.5, negative 3.25. How else could I find the vertex? Well, let's go that route in part B. What's the vertex of that equation? Y equals. On. Y equals. Clear. X squared minus 1x minus 5. Graph it. Okay. Second, calculate the minimum. Enter. Enter. Take a guess. Yes. Okay, so again, interpret it properly. This is 1/2 or 0.5 comma negative 5.25. 0.5 comma negative 5.25 is the vertex. Wow, well that's a lot easier than completing the square. Okay, it just gets better. Help Jenny find the vertex and graph the parabola. All right. Well, I'll do this. I'll do the completing the square for those of you guys that strive to be accelerated. But everyone else, or really even if you strive to be accelerated, the fastest way to do this is using this wonderful TI-84 Silver Plus Size Edition. So, watch this. 2 times x squared minus 6x plus 17. So the first thing I did was I undistributed. Okay? That's called factoring. Now, it's 2. I'm just going to create space. Half of negative 6 is 3. 3 squared is 9. That is called completing the square. But what have I really added? Have I added 9? I have not, because there's a 2 here. I've added 18. So in order to keep this teeter-totter balanced or level, I've got to subtract 18, and that is not easy. So h of x, what is it? Well, it's 2 times, well, this thing right here is x minus 3 times x minus 3. And 17 minus 18 is minus 1. So what's the vertex? It's positive 3, negative 1. What's this graph look like? Well, it's going to open up twice as fast. Oh my gosh, maddening, maddening. Just going to go with it. There we go. Okay, so I know that it's going to be right 3, yep, down 1. There's my vertex. But honestly, I'm going to need my graphing calculator to get the points. So I should have just probably put it in my graphing calculator in the first place. 2x squared minus 12x plus 17. I'll graph it just to take a look at what it looks like. Notice it's steeper. Let's go to the table. We'll scroll down to here till it starts to make sense for our numbers. So 1, 7. No, sorry. Yeah, 1, 7. 2, 1. 3, negative 1, 4, 1, 5, 7. Last one. Okay. You've got to try it. Find the vertex and describe the parabola. That is the graph. Well, how about I just do it real quick in my graphing calculator. Clear? Y equals 0.5 x squared plus 2x minus 3. Graph it. Calculate. Minimum. Notice this graph is wider or fatter because of that 1/2 in front of it. This is a frustrating part of doing this on the computer, is it takes much longer than it does in your actual graphing calculator. But man, I feel much better about this lesson than I did when I was trying to teach it to Carson on Tuesday. Carson, I hope you're warm, buddy. Hope you're enjoying your day off. Alright, so, what the heck? Guess, yes. There we go. -2, -5. Love it. The vertex is -2, -5. Notice the half in front here. So I think in vertex form, we could write f of x is 1/2 times x plus 2, quantity squared, minus 5. I bet those would be equivalent things. Describe the parabola. It is a wider parabola opening up with a vertex at -2, -5, and I kept it under 20. Boom!